Replacing eye trackers in longitudinal studies. A comparison of eye tracking data quality between the Tobii Pro TX300 and the Tobii Pro Spectrum. In youth, we use several research methods to study the development of children. One of these methods is eye tracking, with which we can study looking behavior. In youth, we use the Tobii Pro TX300, a very nice piece of technique. A problem, however, is that the eye tracker can age and break down even before the cohort study has ended. This has already happened to one of our 3 eye trackers. In this case, you might have to replace the eye tracker. However, the TX300 is no longer being manufactured and sold. Tobii Pro does have a successor, namely the Tobii Pro Spectrum. Eye trackers differ in their specifications, for example in the quality of data they produce. So what we did in this study is that we compared the data quality of both eye trackers for 3 age groups, 5 months, 10 months, and 3-year-old children. Data quality says something about how good the data is that you collect, and it is often defined through precision, accuracy, and data loss. So imagine someone looking at one location at a screen. In these cases, it is represented by the red crosses, and the reported gaze positions by the eye tracker are represented by the black dots. Precision is the reproducibility of the gaze position signal, so the black dots here returned by the eye tracker. Good precision is the little variability between the dots reported by the eye tracker, and you can see that here. Bad precision would be a lot of variability between the dots, and you can see that here. Accuracy is the distance between the gazed at location and the reported position. So imagine taking the average position of these dots. You would end up close to the gazed at location and would conclude accuracy to be good. However, in this case, the average of the dots would not be close to the red cross, and you could therefore conclude accuracy to be bad. Data loss is the proportion of missing gaze position signals when a gaze position signal was expected to be produced. What we found in our study is that overall the spectrum produces better data quality, so that means better precision, better accuracy, and a smaller proportion of data loss than the TX300, especially for the 5 and 10 months old. Now, you might be thinking, great, an eye tracker which produces data with better quality. Let's just replace it, no problem. However, that is not the case, because data quality may affect outcome measures of an experiment. Let me give you an example. Imagine we put someone in front of the eye tracker. If we were to plot the gaze position signal with dots, it might look something like this. So here we see gaze position starting somewhat above the center, then moving down, then moving up a bit, then moving a bit to the lower left, etc. If we were to plot this over time, it would look something like this. So in the upper figure you see the horizontal position on the y-axis and time on the x-axis. And in the lower figure you see the vertical position on the y-axis and time on the x-axis. You can see in the lower figure again that the gaze position started somewhat above the center, then moving down, then up a bit, etc. Now, if we were to look for fixations in this gaze position signal, we would use a fixation classification algorithm, and we would probably conclude there to be 5 fixations. Now, the precision in this example is pretty good. Imagine the precision to be worse. Then the gaze position signal would look something like this. Now, if you look in the lower figure, you would probably conclude there to be 3 fixations. The smaller fixations are in this example covered by the noise. Now, imagine that in our youth study, we study an infant. She comes by at 5 months of age and we run an experiment with the TX300. Precision will be probably comparable to this figure. 5 months later, she is back for another measuring day, but in the meantime, we have replaced the eye tracker. We would now do the exact same experiment, but the data quality would be much better. This would mean that if we were to draw some conclusions based on this experiment about the development of this child, These conclusions would not only be based on some actual development, but also through the improved data quality. This is clearly a situation you would want to avoid. This example only dealt with precision, but remember we also have improved accuracy and less data loss. For some of the problems that arise upon replacement, we have some suggestions as to how to deal with them, like choosing a fixation classification algorithm robust to wide ranges of precision levels, but some are harder to solve. If you want to know more, I might suggest you to the paper. The main take-home message is, if you are in the position where you have to replace your equipment with better alternatives, always check what sort of effect the replacement might have on your data and your experimental outcome measures. Thank you for listening.